Hello friends, hope you are all doing well. Our today's topic is data compression in column storage type in SAP HANA Database. In this video, we are going to learn what is data compression, different types of data compression, and its advantages. Data compression is a method of compressing data which consists of repeating or duplicate entries of unique or distinct values. Because of that, it reduces the size of data stored in memory and improves system performance. And this technique can be applied to both row storage and column storage, as we have seen in the previous lecture. But if it is performed on the row store, there will be no impact. So we consider that property applies in case of only column store. Since column store works on SAP HANA database, it has inbuilt feature of compressing data automatically. Moreover, SAP HANA is an in-memory database engine and it always stores the data in RAM, which is also called main memory, rather than storing it in hard disk. We will be learning about this, what is this in-memory database, in the next lecture. Data compression techniques. Here we can see some of the data compression techniques like dictionary encoding, run length encoding, prefix encoding, cluster encoding, sparse encoding, indirect encoding. Let's consider a simple compression technique that gives us basic understanding. Let's go with dictionary encoding technique. This dictionary encoding technique has three components, namely vector representation, dictionary vector representation, and attribute vector representation. Vector representation. It is a database table with all the entries that we can see in the application layer. Dictionary representation. It replaces the actual data with integers to reduce the memory storage. Attribute representation. It takes the integer values which are assigned for each unique value and store them in the database table by replacing original values. We will see each of them in detail. Vector representation. Here you can see a database table which consists some entries in the form of rows and columns, or we can call records and fields. This table, what we are actually seeing, is in the application layer of SAP GUI. I will show you in the SAP system by logging into it. I have logged into SAP system and I am going to the T code S11, and this is the database table which I have created. And if you go to display and contents, execute, we can see the entries whatever we have seen in the PPT. We can see here there are some 8 entries maintained. Here the horizontal ones are called records or rows and the vertical ones are called fields or columns. If you see in the employee last name column, there is an entry with Patel, right? This is called unique or distinct value. But the same entry is present below also, which is repeating. So in this case, it is duty of data compression to show its performance. And there are some more unique values which we can see here. And similarly, in case of employee gender column, we can see entries with male and female. And in case of employee location, we can see multiple entries with Hyderabad, Chennai, and Bangalore. You would get a doubt like, generally in databases, unique entry means only once it will display in that particular table. And mere repetition of the entry again and again won't be called as distinct or unique entry, right? I will make it clear. While creating an entry in the table, as you are entering this value for the first time, database will also think in the same way. Then it will fix as this an unique entry. Afterwards, you give the same entry for the second time. It will consider a copy of the original one. Here we can say for a unique entry, there can be multiple values existing. This is how we can justify, even though there are multiple entries, we can call the first one as a unique entry or a distinct one. Hope you got the answer. These marked fields represent repetition of unique values, but you can see a unique value like Sharma and Mishra, right? These are used only once. Will data compression applies for this case also? The answer is yes. It is because, as we have already seen before, while creating for the first time with that name, it will be unique. But a new record with that same value can be created in future, making the unique entry as repetitive one. Let's see the dictionary representation of each column. In case of employee gender column, for a male entry, a unique integer value is provided by SAP and assigned to it, which is 1. Similarly, for female, SAP assigns as 2. And in case of employee last name column also, whatever the entries we are finding in the database table, for each and every entry, SAP assigns an unique integer value. The same happens in case of employee location column also. The actual data will be stored in case of dictionary representation, and the assigned unique integers will be stored in memory location of SAP, which is in RAM, because it is an in-memory database. And here, instead of string values, numbers are represented because this can be easily processed. This you will be get to know soon. So totally they are of 3 columns. So 3 dictionary vectors are created. Now we will see the attribute representation of each column. Firstly, it is employee gender column. In the dictionary representation, SAP has assigned 1 to male and 2 to female, right? So in the attribute vector, it will replace with those original values. And how does the values get assigned from dictionary vector to attribute vector? As numbers which are replacement of original values are stored in the memory location, right? These are derived from the dictionary representation with the matching original values and get stored in the database, which is in the database layer. So whatever the actual values are there, those all will be replaced with the integer values in case of attribute representation of employee gender column. So here, instead of string type of values, numbers are stored in the backend so that integers can be easily processed compared to string, as the latter one needs more memory allocation. Similarly, in case of employee last name column, we can see integers deriving from dictionary representation to attribute representation and replacing this with integer values. And also for employee location column also the same works. And in all these 3 cases, we are not deleting the original data. We are just compressing and converting into integers for fast processing. And here you can see how data is maintained in 2 database tables. First one, it is vector representation, which is in the application layer. And second one, it is attribute representation, which is in the database layer, that is in the backend. As these 3 columns are participated in data compression and strings are replaced with integers, let's see memory allocation for each and every field. And we know that in case of string, for each character, it will take 1 byte of memory, and for integer, it will take 4 bytes. So in this employee last name column, summing up all the entries will gives you 42 bytes of memory. The same if we represent in integer, it stores within 32 bytes. So here 10 bytes of memory is saved. The string data can be even more, but integer data will be constant. Here, as I have used only less number of characters, so it is not making much difference. Similarly, in case of employee gender column, it occupies 40 bytes, and in case of integers, it will take 32 bytes of memory. And in case of employee location, it takes 64 bytes of memory, and in integer format, it stores 32 bytes of memory. And this is the reason why data is stored as numbers in the backend. Space occupied in the memory will be reduced, and while fetching or feeding or any database operation is performed on a database table, we can achieve output with faster processing. This is all about the data compression and storage allocation. Advantages of data compression. It requires less memory storage. It accelerates data transfer from main memory, that is RAM, to CPU, and faster processing of integer values. Since the data is stored in RAM and it has less memory space, so to store the database entries, we need very less data as it has less memory space. When the data is processed, we have to take it from memory and put it into CPU. CPU has registers and caches, those kinds of things, which is faster than RAM. So at that time, having less data is very advantage. So instead of string data, integer data is passed to CPU for fast processing. Let's go through some key points what we have learned so far. In case of dictionary vector, the data is stored in memory, or we can call it as RAM. And in case of attribute vector, the data is stored in database server, which is in the backend. Here, actual values that can be of integers or characters or strings or whatever the data the user has actually stored, that will be seen in case of dictionary vector. And in case of attribute representation vector, the whole data whatever the user is maintained in the dictionary vector can be converted into integer format for fast processing. Thank you friends. Hope you enjoyed the session. Our next video will be on in-memory database in SAP HANA. Until then, keep learning and share the knowledge. Thank you once again. Jai Hind.